Hello, today we're going to be working on 6.4 day 2. That's going to be geometric sequences. So as a reminder from yesterday, a sequence is geometric if you are multiplying by the same number each time. Even if you're dividing, we write that as multiplying by a fraction. A sequence is arithmetic if you are adding or subtracting to get to the number each time, and it has to be the same number that you're either adding for arithmetic or multiplying for geometric. For geometric series as well, or sequences, our formula is going to be a sub n equals a sub 1 times r to the n minus 1, where a sub 1 represents your first term, so whatever number comes first in your series sequence, and r represents your ratio. So that's whatever you're multiplying by to get to the next number. So for examples 1 through 4 here, we just want to look at them and identify the pattern. And then based off of that pattern, we want to say if it's arithmetic or geometric. And if it's geometric, we want to find our first term and our common ratio. So for number 1, we have 5, 8, 11. The next one would be 14 and so forth. So what's happening here is you are adding 3 to get to your next number. Because it's adding, we're going to call this the arithmetic sequence. This next one, 1/10, 1/2, 2.5. So these ones are kind of hard to tell. So looking at this, you might want to use your division to work backwards. So we're going to do 1/2 divided by 1/10. And as you are doing that, you do want to make sure you have parentheses around this if you're using your calculator, so that when you divide, you make sure you're dividing by 1/10 and not just 1 and then multiplying by 10. So try this on your calculator, because when you do that, you should get 5. If you don't, that's maybe an issue with your parentheses. So try it on your calculator, see if you get 5. And then let's check this. If we do 1/2 times 5, we would get 2.5, which is 2.5. So therefore, because it is being multiplied by 5 to get to the next one, that's going to make it geometric. We also want to find our first term. Our first term is just whatever came first in the sequence, which makes it 1/10. And r is our common ratio, which was a little harder to find for this one, but it ends up being 5. So let's take a look at number 3. I can tell my numbers are getting lesser. I'm subtracting a lot this first time and then not as much the next one, so it's not going to be arithmetic. So I'm going to test for geometric. So I'm going to do 27 divided by 81, and I get 1/3. And I can also test the next one, 9 divided by 27. I also get 1/3. So what's happening here is to get from one to the next, I'm actually multiplying by a factor of 1/3. That means that this is going to be geometric. My first term here is 81, and my common ratio here is 1/3. So for the next one, I can look at these and I can say, well, wait a second, 4, 6, 8. I know they're all negative, but these are all only 2 apart. So I'm going down by 2 each time. That's going to make this arithmetic. So now what we're going to do is we're going to take a look at something that is geometric, and we're going to go ahead and find the rule, and we're going to use the rule to find the 10th term of our sequence. So our rule, as a reminder, is a sub n equals a sub 1 times r to the n minus 1. We need to know our first term and our common ratio. And our first term here is actually given to us. It's 3/8, which means right away I can plug in 3/8. So the only thing I really need to find is my common ratio. So I'm going to go ahead and use the same idea that I did on the last one. I'm going to take -3/2 and I'm going to divide by 3/8 to find my r value. Now, as you're doing this, once again, you're going to want to use parentheses. Try this one more time on your calculator. Pause the video and actually type this in and see what you get. So we should get -4. And so if we test that, what's happening is we are multiplying by -4 to get from one to the next. And so we do -3/2 times -4 just to verify, and we end up with 6, which means my common ratio here is going to be -4. So plugging both those in gives me my rule. To find my 10th term, what I'm going to do is, this is another way of saying a sub 10. 10 is going to be my n value. So I'm going to do 3/8 times -4 to the 10 minus 1. And so you're going to do 10 minus 1, and you're going to really do 3/8 times -4 to the 9th. And so you're going to type this in on your calculator just like that with the parentheses and everything, and you should get -98,304. If you don't, put a star next to this, and we can talk about it in class so that we can make sure you're using your calculator appropriately. So now we have an example of people who have the flu. It's 8 people and 48, 288, and so forth. This is a geometric series. What we want to do is we want to go ahead and we want to write our rule. So our rule, we need to know our first term and our common ratio. So our first term is just 8. So all we need to know is what are we doing to get to the next term. And so if we go ahead and take 48 divided by 8, we get with our common ratio to be 6. And so you can test this if you want by plugging in the fourth term. If you plug in 4 up here for n, you should get 1,728 back out. So let's go ahead and take a look at this one. It now is talking about attendance for the Judson University basketball team. So we have these 3 different games here. 18,000 was the first one, then 9,000 and 4,000. So we want to write our rule. So our first term here is 18,075. Then we want to find our R value. So what are we multiplying by to get to the next term? So for this one, if we do 9,038 divided by 18,075, we end up with 0.5000027, and it keeps going there. And if we do the next one, 4519 divided by 9038, that ends up being 0.5. So these aren't exactly the same, but what's happening here is you're talking about people. So I think some rounding occurred so that we didn't have to deal with, like, we can't say 9,037.5 people. So we're going to say that our rate for this one is 0.5 or 1/2. And again, it's just very, very slightly off, and that's because, again, we're talking about people. So our rate is 1/2. So for this next one here, we're going to go ahead and plug in 7 for our A value, or A sub n. We get 18,075 times 1/2 to the 7 minus 1. When we do that, we get 282.42, which once again, we're talking about people. So we're going to say 282 people showed up to the 7th game if that kept on going with that pattern. So that's it for the day 2 stuff. Now we're going to go ahead and review some of the chapter 6 stuff, just because we have our test upcoming next week, and I wanted to make sure that everything was going well with this. So looking at this, number 8, when we have all of these raised to the 3rd power, we're going to raise everything to the 3rd power. So we do 3 cubed. We're going to do a to the 6th when we multiply that, and then b to the 15th. And then c to the -12. So raise everything to the power. Now we're going to move negative exponents around. So the c to the 12th is going to go to the denominator, and it's going to become positive. 3 cubed, I can do 3 times 3 times 3 to get 27. And a to the 6th and b to the 15th have nothing else to do, so that's going to be our final answer. So let's take a look at number 9. We're going to raise everything up in the numerator here to the -2nd power. So we do 5 to the -2nd, x to the -4th, and y to the +8th. when we multiply those. We have 4 to the negative second, x to the negative ninth, and y to the 0 just becomes 1, so I'm not going to write that. Next, we find all of the negative exponents, and we're going to move them around. So y to the 8th stays where it is. The 5 squared and x to the 4th moves to the denominator, while the 4 squared and x to the 9th moves up to the numerator. Then I can go ahead and simplify. 4 squared becomes 16. 5 squared becomes 25. I have y to the 8th in the numerator. And then for my x's, I have 9 in the numerator, 4 in the denominator. So 4 would cancel out, and I would be left with 5, and they would be in the numerator. Or you can do 9 minus 4 to get the 5. So now we're also going to review graphing. So looking at this equation, our a value is out in front, our h value is up with the x, our k value is at the end, and whatever is being raised to the power, that's the base. So a is 3. Because a is 3, I'm going to zoom out just a little bit. Because a is 3, that is going to be a vertical stretch of 3. Our h value, we're going to do the opposite of what's there. So since it's plus 3, it's actually going to be minus 3, and that's going to move your graph to the left 3. Your k value is minus 4. That's going to move your graph down 4. And your base of this is just 2. And so what we're going to do is we're going to go ahead and write our x values. Our x values are -1, 0, and 1. Our y values are 1 over the base, 1, and the base. So since my base is 2, my first one is going to become 1/2, then 1, then 2. I'm going to add h to my x values. So in these cases, I'm actually going to take and subtract 3 from each of them. So -1 minus 3 is -4, 0 minus 3 is -3, and 1 minus 3 is -2. To my y values, I'm going to multiply by a and add k, which means I'm going to multiply by 3 and subtract 4. So times 3 minus 4 for each of those. So if I multiply by 3 and then subtract 4, for my first one, I'm going to end up getting -2.5. For my next one, I'm going to get -1, and then 2 back out. Before I graph, I'm going to go ahead and do my asymptote. My asymptote is always going to match my k value, so it's going to be y equals -4. And I can graph that horizontal line on my graph. I would like to see that on your graphs. Your domain is always going to be -infinity to +infinity. And now we can graph it to find our range as well. So -4, -2.5, -3, -1, and -2, 2. And we connect this and make it look like that exponential function. So my range from low to high starts at -4 and goes up for forever. And this one here from left to right, everything is growing. And my base is 2, so that backs that up. So if your base is greater than 1, it's growth. If it's between 0 and 1, it's decay. So thank you very much for listening. I hope this helped.